And for the volume, then, based on what we've done. Say again. Sure. 30 seconds, try to come up with an expression for the length based on what we did with the width, and try to come up with an expression for the volume.
Wait, is that one the same though? Because that one would be minus 2h, but this one didn't go by the same length, did it? Oh yeah, I did go by 2h.
So how did we get the 10? We took away the 1, how many times?
12 minus 2h.
Yeah, right.
I don't know how we're supposed to get that answer. I mean, I can get a formula, right? H times 18 minus 2h.
Alright, let's quickly talk about it. LaShannon, what'd you come up with for the length?
I got 12 minus 2h.
Anybody want to push back on that, or do we agree?
I don't think we know.
Say again.
I don't think we know.
You don't think you know?
Let
Okay.
me try.
LaShannon, how'd you get that? 12 minus 2h.
Well, I had to the 0, the length, and 12. You know what I mean, right?
Yeah, that 12 that we started with.
And since you subtracted 2, each time you go down, I put minus 2h for the height.
Okay, and that's a good thing to notice. If we're repeatedly taking away 2, what would be the slope of this expression? 2. So minus 2h, you could think about that as your slope-intercept form, y equals a plus bx, right? Does anyone have another way to explain where the 12 minus 2h is coming from? It's the same thing we did last time, right? What number are we starting with every time? 12. Here, how much do we take away? 2, how many times? Here, we started at 12, we took away 4, how many times? Again, what stays the same each time is going to stay the same in my expression, right? And then what is changing is going to be my variable, and notice how the variable matches that h, the height, or the corner amount that we're taking away. So then how would I calculate my volume?
We should still do a
I'm going to put them all together and combine like terms.
I did say that one more time.
Like, you know, you multiply them all together.
Right.
I combine like terms. Is 2h or negative 2h, whatever, supposed to be 4h once you do it, or is it supposed to be 2h squared?
Okay, let's talk about that. How are we supposed to calculate volume?
Length times width times height.
So what is my length here?
H.
Nope. Length.
12 minus 2h.
12 minus 2h. Times my width, which is times my height, which is h. There's my volume. Length times width times height. And so remember when you were stressing about that 30, right? Like if it was 30 down the line. Well, can't I just substitute 30 in for h?
Mm-hmm.
Now we'll point this out. Can we actually have an h of 30? Look at the table. Why not?
I mean, you could go as far as you want to go,
But in the real world, can we? What kind of volume are we going to get?
And negative.
A negative volume. Can we have a negative volume? No?
So you don't need to combine any of the negative 2h.
Actually, let's check that. I don't know that we would
Because
get
my
negative
last
volume.
answer was h times 4h times 216.
Hold on one second. Can y'all put this in your calculators and see what we get? So that would give me negatives, 48 times negative 42 times 30. Does that give me a negative volume? 60,000?
Yeah, 60,000.
Okay, so it didn't give us a negative volume in this case, but is that still a possibility? Why not?
Well, no, that's a really good box.
Not just that, can my length be negative? Even though I'm getting a positive volume, can I have a negative length? Can I have a negative width? No.
Wouldn't that just mean it doesn't have sides and it's actually just going into the ground, like a hole?
It's, no,
Does it have
because
volume
here's
or
the
not?
thing, well, it has volume, but here's the thing, think about what we're doing is we're cutting squares. The longest side, or the shortest side I have is what? 12. Can I cut more than 12 out of that sheet of paper? No, so that's the last h we could have. I would still, in that case, have no volume. Okay? We go with that idea?
How you get it?
What? This? Plug into a calculator. 12 minus 60 is negative 48. And because that's just 2 times 30. 18 minus 60 is negative 42.
What'd you do with the H?
We talked, so this whole started because I was like, can you have an h of 30?
Oh, they don't go with.
So I substituted the 30 in to see if we could have an h of 30. And that came about because Gracie was talking about, well, if I go further down the table and I get a 30, she was talking about this earlier in her small group, is that I couldn't do that. And I was like, well, if you have an equation, you can, but that's still not possible in this context.
I'm just confused that we don't do anything with the like terms, because I always like the one, you know, if you got two
You're
of
thinking
these-
about adding and subtracting. Am I adding and subtracting these factors? No. Could I multiply them and then combine like terms? Yes. Do I want to? Not if I don't have to.
So that would be the answer. I ain't talking about the 30 thing, I'm talking about the top one.
That's like the
This would be the equation for number 3. And I will point this out, does anyone know what we might call this form of the function? It starts with an F. Is it factored? Does this kind of look like x minus r1 times x minus r2? Except now we would have an x minus r3. Because what kind of function do you think this is? We're multiplying 3 linear expressions. Remember when we multiplied 2.
So you said something with
Well, remember when we multiplied 2, that's when we ended up with an x squared, which we said was quadratic. Right. So this would be x, what? Or in this case, h cubed, which would be a cubic. Mm-hmm.
Why do I call it cube? Because a cube literally has nothing of, like, with a 3 on it. Like, it has 4 sides, or, well, more.
That's a cube.
I know, but what does that have to do with 3?
It's 3 dimensions. A cube is 3 dimensions, just like a square is 2 dimensions, length and width. Alright, so let's move from here to the next little part of lesson 3. So, I need you to pay attention to this. There is a definition for a standard form of a cubic function on 3.1 on the next page. A cubic function is a function that can be written in the general, or we always talked about the general as the standard.
Is that on this sheet or the other one?
It's on the next page, it's on 3.1.
No, I'm saying, like, you said there was a definition, is that on
Don't
the
forget your
sheet?
equation. The definition?
You said there was a definition for something, like, is that on this?
I mean, do you see cubic on there?
Oh, I just,
Okay. Now, I will point out there is more that you should be able to add to the cubic than just that definition, because what rate of change do we talk about a cubic function has? A quadratic rate of change. Remember, a cubic function has a quadratic rate of change, so you need to add everything you can to it. So I want you to notice where we had ax squared plus bx plus c, now we have ax cubed. Hey, y'all are talking over me, I need you to pay attention to this. With a quadratic, we had ax squared plus bx plus c for the standard. For a cubic, we now have ax cubed plus bx squared plus cx plus d, right? Notice how it's decreasing in the power by 1 every time. Okay? And so, hey, hold on, I need to point out, I know that some of us are just trying to go ahead and knock out the graphic organizers. Do that at home. That's not me trying to punish you. Take the 10 minutes at home, use this to help you reflect on the lesson so that tomorrow when you come to class, you are better prepared. I need you to reflect on this outside of class for a few minutes. I want us to look at number 1.
Then I'll go home and look at it.
Huh?
If I have an hour, I'll go home and look at it.
If you have an hour?
If I have an hour.
Oh. You will go home and look at it?
I'm going home with it.
Okay. Lewis, Ahmad, and Heidi each use graphing technology to analyze the volume function and to sketch the graph. Notice Luis says the graph increases and then decreases. It's a parabola. Does a parabola both increase and decrease? Yes. Ahmad says the graph lacks a line of symmetry, so it can't be a parabola. Heidi says, I noticed the graph curves back up, so it can't be a parabola. Who is most correct in this situation?
Heidi and,
Ahmed.
yeah,
So Heidi and Ahmed, so is it a parabola?
no.
No. And I need you to hear me very clearly on this. This is why I said last unit, you cannot just say, hey, it increases and decreases, so it's a quadratic. Because what kind of function is this? We just talked about it. Cubic, right? Does this increase and decrease? Yes. So is it enough to say, hey, it increases and decreases, it's a quadratic function? No. You have to look at the graph and see what is happening. You have to look at the equation, and if it has an x cubed, it's cubic. If it has what type of rate of change again? Quadratic rate of change, right? So we want to pay attention to those kinds of details, but this is where we're mostly going to focus for a second. So when we start talking about these polynomial functions, what we are doing for the rest of this week and what we're focusing on is this idea of analyzing a cubic function. So what I want you to do, right, is within your small groups, so we have this equation that we developed earlier. V of h equals h times 18 minus 2h times 12 minus 2h. Notice the order can go in any order, so I think we did length, width, and height before. This is now my height, width, and length. The order doesn't matter. But I want you to graph this using this window that they indicated. So make sure you change the window settings on your calculator.
With the 18, that was our key.
Remember, that was the width of it. So go ahead and graph.
So the 2h is just what we're going up by each time, so the 18 would be a bit right.
The original the 18 is the original width, and you take away 2h. By the way, can you put h into your calculator to graph? You have to put an x. I heard a question over in group 3.
What do you want to send out when,
What are you supposed to make the window? It's in the textbook.
wait.
It's number 2 in the textbook. It tells you what the window is.
Where do we put that?
What?
Like in the x minimum, x max?
X minimum? Yeah. Oh, that is a good point. Let's point this out. Negative 10 comma 15. Does anyone recognize that notation? That's interval notation, right? Remember how this is the minimum value, comma, the maximum value. We always put the domain or the x values first, right? So that's just interval notation. And then the negative 400 would be the y minimum, and then the positive 400 is the x, or y maximum. Again, min and max. And that's for my range. Do not forget, domain is my x, range is my y. If you didn't already know that, we're going to talk about it more heavily, but just be aware. That was something we should have covered in Algebra 1, and I know that that's not necessarily true for a lot of us, but we'll get there. Yes, Cameron?
I think it's not letting me in. I think I
Did you put h or did you put x for your variable? You have to put it. You have to put multiplication between the x and the 18 minus 2x. Okay. Yeah. Yeah, that's fine. Okay. So make sure you put in x times 18 minus 2x, and then you put multiplication between the x and the 18. Okay.
Which one are you talking about? The first one is oh, 2.
So you're putting x instead of h there.
That's 12 minus 2h.
Yeah, because you don't have a multiplication between your x and your 18 minus 2x. You have to put multiplication.
I knew from the moment it was going to be square.
Show you what. Do what? Type the equation. Is that what you're asking? Oh, everything runs through menu. We're going to go to change your window settings. Yep.
I didn't get it.
There you go. Okay. And then make sure you put x minimum, x maximum, y minimum, y maximum.
I think you're talking about
put h instead of x.
Yeah.
The thing I told you not to do. It's okay.
It's okay.
Maybe 6.
The calculator doesn't understand yours,
I don't understand it sometimes.
man. It's like yelling at your dog to do something.
He's got some.
My dog started being on the couch recently.
Wait,
and
so
Hey, go ahead and start on the answering the questions for number 2 once you get that graph done. Did you change your window like it was?
No.
Yes, that's the window. That is not.
How do you do that? I was gonna wait till
A of 10 to 15. I see what you mean.
I'm saying what button?
Look again. It says a of 10 to 15. I told you that's what it is. It's a domain.
The top and the minimum.
And then look at your y code. Negative 400 to 4.
Go put X.
Yeah, put X now.
Huh?
Key characteristics, alright, there are 3
Okay. So start answering your questions on number 2 once you get it graphed. Yeah. You need parentheses around that.
I told him to put parentheses back. That's what they all say. He told me I did it once.
No, you did.
Okay, yeah, but I didn't parentheses.
How about we focus on answering the questions?
I didn't put the minimum back. Yes.
Oh, here's the issue. That's the real issue. You did times negative 2x. That's why I didn't register your parentheses. It was minus 2x.
You put minimum.
There we go.
And the height.
Okay.
So that, 3 is intercepts.
Okay.
0, 0, 6, 0.
No. Alright, come on. No, we gotta answer some questions.
I got 0, 0, 6,
Is it
0.
graphic?
I mean,
When you're trying to put in the maximum.
Because it's saying key characteristics.
and I will say, like, if you look at Kyla's, I kind of like what she's saying of it increases, decreases, then increases again. Oh, okay. But you just said it increases twice and then decreases. Oh, okay. Because I do like noting the order that it happens. Okay. So just as a quick note, don't spend forever on part A. I want you to spend more time on B, C, and D, and at least identify the x-intercepts.
You gotta make sure to put the X columns, because that's what we're all talking about.
Just what characteristics you can think of. As I said, don't spend a ton of time on A. Focus on B, C, D, and E. Okay?
Do you get something to feel like in the car? Or did like, because everybody has like, goodness, like.
What is the maximum volume? Remember how you graphed that function, right? Wasn't that V of H your volume? So this thing is representing your volume. So what is the maximum volume?
That's it, all the way up there, isn't it not in?
Well, so remember, like, how we talked about we couldn't go past the 6, 0. And so it doesn't continue all the way up to there. That is the biggest piece we can cut out of that
Yeah, I think I did
square.
right.
Okay.
Okay.
Huh? So what is the volume? Is it the x that's the volume or the y that's the volume? The y is the volume. Remember, it's V of H, right? So the volume is your output. So the volume, the maximum volume is what? 228. When the H, the amount you're cutting out, is what? You look confused. We talk about it with Cameron. She found out how to get it.
So how do we know if X is negative or positive?
We can do it. Dude, you typed the equation, the one that's on the board that we wrote for getting started.
Like, if it kept going down.
Were you putting an H instead of an X?
But now it goes down.
Are you sure about that?
So-
Did you remember that I told you like you have to put a
Oh, it's
multiplication
on the- is it- it's on
between
the
the
right
X
side
and
of
the
X
18
and
minus
the
2x?
X? Because boom would be 0, boom would be whatever and whatever.
Oh, there it is. Why didn't you talk to Jaden or Nathan? They both had this already done. You're sitting there just doing nothing. What are we thinking about? Thinking about writing down? You don't know how to do what?
On A, we're putting, the
Part
parabolas on the
B,
back
what is the
side.
maximum volume? Well, remember, you put in x's and it's f of x, but then if you start out with this,
Up positive, well, we don't really know now because it goes up and then down in them, so. Parabolas on the right side, so it's positive, I'm guessing.
Grayson, focus on the math we're learning now.
Yes, sir.
Thank you. So where's the volume? Is it my input or my output? Notice what's my input?
Okay, what's the maximum
The
volume?
h. Remember, that ends up being the height, but it's how much we're cutting out. So the volume is my output. But, so look at the graph. Where do you see the maximum volume? But remember, could we, I would say, we see a maximum up here, and remember, could we go past 6?
This is flat.
Remember how we talked about the fact that once we get past 6, or get to 6, we get 12 minus 2 times 6 is 12. Can we go past an h of 6? Huh? So remember, if I put an h of 7, 7 times 18 minus 2 times 7 times 12 minus 2 times 7. That gives me 7 times 4 times negative 2. Can my length be negative? So could I go past the 6? No. Right? Notice, can I get negative volume? So if I get to those negatives, it's not possible. Right? So I would have to stop at h of 6. So the maximum would have to be somewhere in here. How would we figure it out? Mm-hmm. And then what? Analyze that graph.
Oh, wait.
There you go.
Isn't that length with volume?
Yeah.
I don't know if we're supposed to be raising them because.
That's fine.
I just don't have the domain.
That's the maximum volume.
It's the width.
You can't get domain from that.
Yeah, you can't.
Think about domain. I told you earlier, it's referencing which values. The x. So think about your x values. So is it going to continue going to the left or is it going to stop right there?
Width is like.
It's going to continue going to the left. So what is the lowest x value that you can get? Negative infinity. Right? That'd be my minimum. Not negative, negative infinity. Is it going to continue going to the right? So what is the maximum x value you get? Positive.
Are we right on the fact of, you know how we used to be able to tell if it was positive or negative by the concavity, but now it does this? Is it by which side of the x-intercept?
So what I will point out is there's not one concavity. This is now concave down, and this part's concave down.
So there's no way to tell if the x is gonna be negative or positive just by looking at
No, that's
that?
for 3 dimensions.
Because usually we could look at the
When you
graph.
mean the x or do you mean the concavity?
Well, that's what that one right there.
Remember, A was the concavity.
Oh, I think it's
No. Because remember, it was A times x squared plus bx plus c. Remember, it's the coefficient.
Because that's how
What's the one that, does factor form not have to go?
Yeah, it's A.
I know, that's what I was saying.
That's not your x, that's your A. It's the same A. A is defined as
Okay, yeah,
concavity.
but I'm saying like if I got this and put it in there, that would be exactly where the x is. So I thought if that was negative.
But x is a very, there's a way to do concavity with calculus, but you, for now, anything beyond quadratic, we're just gonna have to do it from the graph. Really?
No, I didn't. I was hot for it. It was cold outside.
we got so far?
Okay.
How do we not know? Okay, what did you get? Okay, so you got the 228. But what do we mean by domain? I talked about it on the board. Well, so that's the domain of our window talking about x or y. You use your eyeballs. I'm not being sarcastic, I'm being for real. Look at it. Is that going to continue going down?
So we're looking for
Yes,
the height.
is that an X or is that a Y?
I figure it's not.
I'm 2D.
Okay, that's Y. Is it gonna continue going to the left?
Same or different in the terms of the concept?
So it's never gonna stop. So what is the furthest number to the left in the X direction?
All graphs
domain.
continue
On here, it's negative 10. But remember, I didn't say it was gonna stop here.
Yeah.
The minimum would be negative infinity.
Where it starts, so
What would the maximum be?
Negative, positive is.
Yeah.
So,
That would be the domain. This is all X values that you can plug in.
how do I work?
Kind of, we'll talk about it more in a second. How do you know if it stops? With a polynomial? Yeah, it would have to be a set.
I get that, like, right here to right here, it'd be your domain.
Right. We'll get some more practice for that, but yes.
Oh, no, no.
No, is that it? I'm just saying.
When it
That's
means
fine for now, we're gonna talk about
When
it.
it says dimensions, it's not dimensions of the shape.
What are you talking about? Oh, the dimensions of the box, yes.
I knew it. So it's height and.
How do you know the box has a
No, it doesn't look This is the box that we did at the beginning of class. It's still that volume that we're talking about.
I'm just so confused. I was like,
We were all like a plant spot.
Alright. So let's talk about this really quickly. I know that we're not quite done, but group 3, Kyla, what was the first thing y'all wrote down about key characteristics? So it increases, it decreases, and then increases again. So I want to point this out. That is actually one of the 5 key characteristics that we need to learn about. But we need to learn how to actually write it. Not just saying it increases, then decreases, and then increases again. We're going to learn how to write that. Not today, but hopefully we'll get to it tomorrow. So be aware, we're going to have to give more information about increases and decreases. Did anyone have any other key characteristics that we should think about?
It's on the right side of the axis.
it's
You talking about the y-axis? I mean, does it continue to the left side of the y-axis though?
Yeah,
Okay, so let's think about that actually really quickly. Left versus right.
negative.
What variable are we referring to there?
Positive and negative?
Well, which variable?
Oh, the X.
The x variable. Would that be maximum, domain, range that you're referring to there? You just said left versus right is x. That's our domain. We need to remember that what we're talking about when we say domain, what we are talking about is all inputs possible for the function. And which variable is our set of inputs? The x, right? I say inputs intentionally because when we originally wrote this function, the volume was not x, or the input was not x, it was h, right? So when graphing, the input has to be an x. But when we're talking about domain, we're talking about all inputs possible for the function. And that's an important distinction that we're talking about here in a second. So when you look at your graph, is it going to quit going to the left? So what is the minimum domain value? Negative infinity. That's my minimum. Is it ever going to quit going to the right? No. So that's going to be our maximum is going to be infinity. Why am I using parentheses here instead of brackets? They use brackets up here. Remember, the brackets are where you can equal the number. The parentheses are when you cannot equal the number. You can't ever equal infinity. But that's our domain. And so you may want to make this note of function never quits going left or right. Right? That is why we're getting these infinities. Notice I'm not just putting the answer, I'm explaining why we're getting that answer. It never quits going left or right, so it's negative infinity to infinity.
So is that kind of going to be the answer for all of them though, because they all do that?
Not every function does, and so it's important to recognize here. Now, we'll also point out, it says, is the domain the same or different in terms of the context of this problem? If we're talking about the context, what is the minimum h value? Think about the context of the problem. What is the smallest h that I can actually cut out? Remember, we are talking about this box right here to create, we're talking about this sheet of paper that we cut pieces out. What is the smallest amount that I could cut out? Not 1, not 2, how much? 0. I could just not cut anything. So the domain in the context would be a 0. Would that be a bracket or a parenthesis? A bracket. You technically could kind of, depending on how you argue it, cut out 0. What is the maximum that we said we could cut out though?
7.
Look again at your 7 on the table.
Oh. 6.
We're not going to cut out 12, we're going to cut out how much on either side? 6, right? Because remember that maximum was 12, so I'm cutting out the 6 2 different times. Right? So notice that's different. The context limits the actual domain. So we have a domain for just the general polynomial function, the general cubic function, but if we include the context, that context can change things. And that's an important distinction to have. That function could continue forever, f of x could. But v of h, the volume, no, we're going to have to limit that domain.
I thought it meant the context, like looking at the graph, not the actual number, so I was thinking like, yeah, instead.
But notice the context is the context of the problem. It's the box that we're creating. Does that distinction make sense? So when we actually talk about the graph and the f of x, that's no context, right? That's just a general function. So if we talked about left versus right, our domain, what's another key feature we want to think about? Domain, our x, is one key feature. Range, right? So notice for f of x, what is our range? What's our lowest y value that we could get? Negative infinity. What's the highest y value you could get? Infinity. But for the context, for the v of h, what is the actual lowest volume you can have? The 0. Right? You can't go below 0 volume. And looking at your graph, this is kind of based on part B. What is the highest volume you could actually have?
224.
Nope. It's close. 228. Notice, DJ, you looked at the table, right? But does that table give us the actual highest? Well, no, because there's decimals out in there at some points, right? Where do we have to find the actual highest value? On the graph. So the context, the max